Okay, welcome to video number 2 in this little series about deriving the equation of an exponential function. Hopefully you have watched the video about method 1, but it's possible you're watching this one first and maybe that works with your learning style. Method 1 is the easiest method, method 2 is almost as easy, and method 3, which I will teach also in a third video, is almost as easy as method 2. They're all easy. Once you know them, they're easy. That's the way it is. Okay, so I've already done a video that shows how to do the tests for linear and quadratic, so I'm not showing those in this particular video, but I'm still going to show the last test I normally do in this course, which is the test for exponential. That is the constant ratio or constant quotient test. That involves I'll start with this one, taking the second y and dividing it by the first y. Looking at the y coordinates in the table, so 12 divided by 6. Then you do the third divided by the second, the fourth divided by the third, etc. So we can see what's going to happen here. It's quite an easy one because we don't have complicated looking decimals. 12 divided by 6 is equal to 2. 24 divided by 12 is equal to 2. We're already thinking this is an exponential. 48 divided by 24 is equal to 2. We are constantly getting the same answer when we look for the quotient or ratio, and that means it's exponential. So I'm going to do this one as well. A little more complicated to look at. You might want to grab a calculator for it. I will. So second y divided by first y is 5.40 divided by 3.18. 5.4 divided by 3.18 is equal to 1.6981. Okay, it rounds to 1.7. 9.19 divided by 5.4. 1.701, slightly different, but it still rounds to 1.7. So we know this is an exponential. 15.62 divided by 9.19, 1.699, etc. It's also rounding to 1.7. So this one, the answers kept on being really close to 1.7, whereas with this one, the answers kept on being exactly 2. The difference is that all the values in this table of values were put in there without rounding. But with exponential functions, very often you have to do rounding. You often have a lot of decimals involved. So when I made this table of values, all of these values were rounded, which means that the answers I get when I do my tests are really close to 1.7, but they're not right on 1.7. That still means it's exponential. When they all keep on being really close, it's because it's caused by the rounding. Okay, now we have to find our equation. In method 1, it was really easy and fast because the first step would always involve plugging in the point that had an x-coordinate of 0, a y-intercept. But these two table of values don't have that point, though, don't have an x equals 0 or an x equals 1. The lowest x value I have is 2. But of course I can still do this. And I'm doing pretty much the same process as method 1 and method 3. It's just that some of the little details in the steps are slightly different. So what I'm doing is I am writing the form for the exponential equation, which is y equals ab to the x. And then I am going to plug in 2 of the points into that form and put them one right above the other. And now what I want to do is take a point that's lower and put it on top. I'll do this the easiest way it can be done. I'm going to pick the second point and the first point. So 3, 12, and 2, 6, when they're plugged in, will give 12 equals a times b to the 3, and 6 equals a times b squared. Then I divide the equations, which is weird, but yes, we can do that. We can add, subtract, multiply, and divide equations if we want. So I'm dividing. That's why I want the one with the larger numbers on the top. So when I divide, the great thing that makes this whole process work is that a divided by a cancels. So the a's are just canceling, and that gets them out of the way. That's what we wanted. 12 divided by 6 is equal to 2, of course. And b cubed divided by b squared, if you know your laws of exponents, if you know how to do divisions with exponents, is equal to b to the 3 minus 2, which is b to the 1. It's equal to b, which means we found our b. Okay, that happens nice and easy because 3 is just 1 unit larger than 2. But that's part of method 2. Method 2 is nice and easy. Well, we like all the methods because they're all easy. Okay, so if b is equal to 2, I can rewrite my equation y is equal to a times 2 to the x. Now, if you watched the method 1 video or are already familiar with it, you will have noticed that the first step involves finding the a first. But with this method, we find the b first. Doesn't matter, we're still going to find out the a. in order to find out the a, it's faster and easier. We don't have to use 2 points. We can use 1 point. We can use any of the points. I'll choose this bottom one, 548. I plug it in. Y is equal to 48, and x is equal to 5. So I have 48 equals a times 2 to the 5. 2 to the 5 is equal to 32. So I have 48 equals 32a. My chalk's getting a little bit messy here. And then if I divide both sides by 32, these cancel. Is this going to fit in my video? Yes. A is isolated and it's equal to 48 over 32. I think that's 1.5. Yes, it is. Which means I know my answer. I have my equation. So the equation, therefore, is going to be y is equal to 1.5 times 2 to the x. And then if we're doing this in a word problem situation, we would probably be in a position where we would want to plug various values into this equation in order to answer the final question. But we have derived our exponential equation. Let's do it again with this one. So we have 2 examples that we're practicing with. I need a bit more chalk. Okay, first step, write the form. Y equals a times b to the x. Second step, pick 2 points. And again, I'm going to pick the easiest looking 2 points and put the bigger one on top. So I'm using the point 3. X is 3, y is 5.40. And then when I plug that in, I have 5.40 equals a times b cubed. And then when I plug in the first point, I have 3.18 equals ab squared. When I divide, the a's cancel. Method 2, that happens. B cubed divided by b squared is b to the 1. That also happens. Of course, it will happen when we have b cubed and b squared. We could have chosen different points, and it would look slightly different, but we'd still be able to do it. We'll see that with method 3. And then 5.4 divided by 3.18, I think I'll use my calculator. Oh, wait, do I have to do that? No, I don't. It's right here. 5.4 divided by 3.18 is equal to 1.7. So therefore, my equation is y equals a times 1.7 to the x. And I want to plug in one of the points to figure out what a is, and the point I'm going to choose this time is the x is 4, y is equal to 9.19, so I plug 9.19 equals a times 1.7 to the 4. Being able to use the y to the x key in your calculator is helpful with this. So 1.7 to the 4 is 8.3521. Now we're just doing algebra. We divide both sides by 8.3521, which takes more time to say out loud than it takes to actually do. Come on, more chalk, please. 8.3521. Cancel, cancel. I'm running out of space, so I'll go over here. A is isolated, and it is equal to 9.19 divided by 8.3521, 8.3521. 1.100, it rounds to 1.1. Therefore, our equation is going to be y equals, where's my a? My a is the 1.1. Y is equal to 1.1 times 1.7 to the x. And yes, I can plug values into that equation in order to answer more questions. So method 2 is different from method 1 because we don't have the point where x is equal to 0. So we do a slightly different step. We end up finding the b first and the a after instead of finding the a first and the b after. But like method 1, these steps become very easy if you practice just a little bit. And you're going to get to the point where you don't care what values they give you in a table of values. You know a method that will work. Stay tuned for the next video, which is about method 3, which is the third and last method that I'm teaching for doing this. And don't forget always to punch that like button really hard and share the video on your social media accounts and do things to make me rich and famous. Thank you very much.